Have you ever wondered why your eye muscles are without a doubt the most active muscles in your entire body? I mean, even when you think you're resting, these guys are just working overtime. Today, we're going to unpack exactly why that is, along with everything else that makes the human eye socket, or orbit, such an absolutely incredible piece of biological engineering. If you want to really understand the anatomy here without getting bogged down by all that complicated medical jargon, well, you are definitely in the right place. Orbit anatomy made simple: bones, muscles, and nerves. So think of this explainer kind of like a blueprint. We're going to literally build the human orbit from the ground up. We'll start with the solid structural foundation. Then we'll add in the moving parts, run the electrical wiring, and finally, we'll install the plumbing. By the end of this, you're going to see exactly how all these complex anatomical structures just work together in perfect harmony.
Section 1. The bony foundation.
Every great structure needs a solid base, right? And for the eye, that protective cavity is built from a surprisingly large number of interlocking pieces. There are actually 7 specific bones making up the framework of each orbit. You've got the maxilla, the zygomatic bone, the frontal bone, the ethmoid, the lacrimal bone, the sphenoid, and the palatine bone. It's like a 3D jigsaw puzzle. Together, they form this shape that looks a lot like a pyramid. The wide base of this pyramid opens right onto the front of your face. That's the orbital opening. But if you follow it all the way to the back, the apex points deep into your skull, narrowing down to become the optic canal.
Now those 7 bones, they don't just sit there randomly. They interlock perfectly to form 4 very distinct walls: the medial, superior, lateral, and inferior walls, along with 4 distinct outer margins. Honestly, think of these walls like a highly reinforced bank vault. They provide the rigid structure needed to protect your delicate eyeball from everyday bumps and impacts, all while giving the internal hardware a solid place to anchor down.
Section 2. The movers, also known as the extraocular muscles.
Okay, here's where it gets really interesting. A foundation is great, but it isn't much use without moving parts, right? Your eye needs to track, scan, and react literally in an instant. So you actually have 7 pairs of these extraocular muscles across both eyes, and they act almost like highly calibrated puppet strings. 6 of them are dedicated exclusively to moving the eyeball itself. That's 4 straight muscles called the recti and 2 oblique muscles. But the 7th one, that's the levator palpebra superioris. Its sole job actually has nothing to do with moving the eyeball itself. Instead, it's completely responsible for lifting your upper eyelid.
What's really wild to realize is that these are not like the standard muscles you have in your arms or legs. Sure, they are technically striated muscles, but they contain these special muscle fibers that allow for just incredibly rapid movements. And because they have to constantly readjust your gaze all day long, they're super resistant to fatigue. But here is the truly mind-blowing part. They do not stop even when you sleep. During the REM, or rapid eye movement stage of sleep, these extraocular muscles are still in there, actively firing away.
So, what's the secret to that lightning-fast speed? Well, it all comes down to the wiring. Normal skeletal muscles have about 1 nerve controlling up to 125 muscle fibers. But in your eye, that ratio is an incredibly dense 1:3 or 1:5. To put that into perspective, that massive amount of neurological wiring is exactly what gives us such ultra-precise, rapid-fire control over where we're looking at any given millisecond.
Section 3. The wiring, or the orbital nerves.
Okay, so now we've got the protective bones and those rapid-fire movers in place. But how on earth does the brain actually communicate with them? Well, if you look closely, you can see a remarkably dense web of cranial nerves passing right through that bony pyramid. We've got the optic nerve, which acts basically as the main data cable for vision. Then we have this whole intricate network of control wires. There's the ophthalmic nerve and all its branches handling sensation, plus the oculomotor, trochlear, and abducens nerves. Those are the ones carrying the vital electrical signals that actually command those extraocular muscles we just talked about. It's essentially a highly sophisticated biological circuit board.
Section 4. The plumbing, also known as the lacrimal apparatus.
Now, this next part is pretty often misunderstood. Tears, they aren't just for crying. They are actually a constant, absolutely vital plumbing system for your eye. And the whole operation starts at the lacrimal gland, which sits snugly in a small depression in the bone at the upper outer corner of the orbit. But what's really fascinating here is that this gland is actually divided into 2 distinct parts, an orbital part and a palpebral part. And guess what's physically splitting it in 2? It's that exact same eyelid lifting muscle we saw earlier, the levator palpebrae superioris.
So how does this plumbing system actually flow? Well, think of your eyelids like automatic windshield wipers. The gland secretes fluid out on the lateral or outer edge. Then every single time you blink, your eyelids literally sweep that fluid across the surface of the eyeball from the outside all the way to the inside, meaning towards your nose. After that, all that fluid pulls up in this little area appropriately called the lacrimal lake.
Once the fluid reaches that inner corner, it obviously has to drain somewhere. It enters these tiny openings called the superior and inferior lacrimal punctum, travels through little tubes called canediculi, and finally ends up in the lacrimal sac. But here's the catch. It doesn't just passively drip down like a leaky faucet. A part of your eyelid muscle actually contracts every time you blink, which actively dilates the sac and pumps those tears right down through the nasolacrimal duct. It's an active, continuous filtration and drainage pump happening all day long.
Key takeaways. The complete blueprint.
All right, let's pull all of this together and recap our complete blueprint. First, we've got 7 interlocking bones forming a highly protective pyramid that safely houses everything. Second, the extraocular muscles are stepping in as our superactive, fatigue-resistant movers. Third, a dense network of cranial nerves serves as the precise electrical wiring connecting the whole system to the brain. And finally, the lacrimal apparatus acts as an active, continuous plumbing system, keeping the whole mechanism perfectly clean and lubricated. It's 4 separate systems working together seamlessly every single second of your life.
So I have to ask you, what part of the eye's anatomy surprised you the most today? Was the fact that your eye muscles are working even while you're dreaming? Or maybe that your tears rely on an active pumping mechanism every time you blink? Drop a comment below and let me know your thoughts. And hey, if you enjoyed this explainer and want to see more complex medical and scientific topics made simple and highly visual, absolutely make sure to subscribe, keep learning, stay curious, and I'll see you in the next one.